Oh,
it's a good just to, yes. So these are the topic. Uh, we were talking about the uh, electrostatic charges and electric potential, and in the last part, one more part is that is the electric potential energy. So we'll talk about that.
energy.
So this is almost our chapter number 12 will be done according to
Oh,
all those topics which you have sent. Now let's see.
yes.
The next is, so all these are actually interconnected. So that's why I'm just working
Electric
on
charge,
these just to
electric
get
potential, and
the
electric potential
information.
energy.
So now let's see if you can read.
Which which materials have charges? A, a dollar bill. B, paperclip. C, a penny. Or D, eraser. Conclusion E.
And
Or
all
E,
material have the
all have
charges
charges.
according to the
Conclusion:
atomic
materials have
structure
charges
model.
according to the atomic structure model.
Yes, this is actually what we can say the electrostatic charge.
Yes. Electrostatic charge.
Electrostatic charge, because
Static
each
charge.
contains the electron, and when we are just doing a little bit maneuvering, so definitely it will get the electrostatic charge. All material have charges according to the atomic structure model, because
Model.
according to the model it has the electrons also. Now let's see the next
Yes.
slide is, so it was a very basic question. Now how do we
Yes.
know if an
How
object,
do we know if an object is charged?
so now let's see, it's a little time to think about that. So how do we know if an object is charged? So this is a very basic question. Let's see.
Yes.
Now it's a just like a hierarchy of
And
all the arrangement.
yes.
So now just
Yes.
this, then I will explain this chart.
There's field, there's three types of field: gravitational field, electric field, and magnetic field. Gravitational field directs towards the center of the earth, electric field directs from positive charge towards the negative, and magnetic field directs from the north pole to the south pole.
So there, if a body is charged, so it will create a field. So
Yes.
now we are talking about the electric field. So the
Electric field.
direction is from positive to negative charge.
Positive, negative
As we
charge.
know that the flow of electron is called the current. So when the electrons are
Yes.
coming from the positive charge body to the negatively charged body, so the movement of the
Body.
electron is actually the current or the charge. So we will talk about
Yes.
only the electric field in this presentation. Yes, if you can read this.
Properties of electric field. It is directed from a positive charge to a negative charge, always perpendicular to the surface, never touches or crosses one another. They are uniform between parallel plates. They are said to be strong when closer to each other.
So these are the properties of electric field. So one way or the other, so anybody can ask that what is the main characteristics or what are the main features of electric field. So anyone
Yes.
can be determined this way, or these statements can be written in a true false statements, or these maybe of the MCQs or the fill in the blanks or whatsoever the format is. But these points you must keep in mind when we are talking about the electric field. So all these features are very much there in each and every electric field.
Field.
Am I audible to you?
Yes, yes, you are audible.
Okay.
Very clear and audible. Electric field lines or lines of force provide a map of the electric field in the space surrounding electric charges.
So now we can see there are the two diagrams, and these are, I think so, are self-explanatory just to talk about the formation of the magnetic field, the lines, the position of the charge, then their direction, then the clustering near the center, and then these
Yes.
are going away from the source charge. So whatsoever, there are so many things, but I think both the diagrams are clear stating what I was talking about all these, and these are the basic and main features of an electric current, electric charge body, the fields, the lines, and whatsoever, the electric field
Yes.
lines. Next is,
Yes. Electric field lines are always directed away from positive charges and toward negative charges.
so this is actually, this is the distinction or distinctive or
Between
very the prominent feature, that electric field lines are always directed away from positive charges and towards negative charges.
negative
So
charge.
our the thing is, so this must be all the time in our mind, that the electric field lines are always directed away from positive charges
Positive
and
charge.
towards negative charges. So
Negative
in
charge.
the last figure, what we were looking at, these arrows are coming
Pointing, yes,
outward.
pointing
So
away,
that is a
out
positive.
of the charge.
And now the
Yes,
situation is slightly different.
yes, away from positive charge.
No, no, it's a negative charge. No, it's towards the incoming. Now look at
Yes,
the,
yes, it's moving away from the
yes,
positive
this
towards
is
the negative.
this was the positive charge.
Positive charge, and it was moving
These are,
away, and that is a negative, and it is moving towards.
yes. So this difference is to be kept in mind, because sometime the diagram is given and we will have to label it right. So this,
Negative charges attract and positive repel, if you
yes.
put
So
it that way.
these are the main features. Now look at
Yes.
this.
Electric field lines always begin on positive charge and end on a negative charge and do not stop in mid-space.
Mid space. Now what we have, the two plates. So if you can see the
Yes.
arrangement, electric field lines always begin on a positive charge and end on a negative
And
charge.
a negative charge.
Do not stop in mid space. So they are always going
Yes.
their destination, that is the negative charge. Now let's see if we can visualize this arrangement. The two parallel plates are placed together and there is a little
Yes.
distance between them. They are apart from each other, and now one is charged positively. So we can say one is positively charged plate and the second one
And
is
one
negatively charged,
negatively charged plate.
and there is a little bit distance between them. So the
Yes.
charge will move from positive to negative, and they are moving in the lines. The arrows in the direction are telling the whole story. So that's why they are not interrupted by anything. They will ultimately reach to their destination, and this is the negatively charged plate. So there is no interruption. They are not changing their ways. They are not changing, and they are just propagating from positive plate to negative plate. So this
Negative
is
plate.
the phenomenon which has been explained over here in what we can say the pictorial way. Then
Yes.
diagrammatically, it's a very much clear, and we will talk about the capacitor in the later stage of this chapter also. Please
Yes.
read
The
this.
number of lines leaving a positive charge or entering a negative charge is proportional to the magnitude of the charge.
So one more thing is, now we are just coming to the mathematical format of these electric field lines, because now
Yes.
you can see in this figure we have the two charges, and as we were talking about that, the lines are coming from the positive charge body and going towards the negative charge body.
Negative charge body.
So their path is different, their sequence is different. They are just coming out and they are entering it. But one thing is that is very much sure, that they are clustering at the source. What I mean to say, the positive as well as the negative charge.
Yes.
And after that, they are getting the
Negative charge.
electric fields. The number of lines leaving a positive charge or entering a negative charge is proportional to the magnitude of the charge. So greater the
Charge.
magnitude of the charge body, the larger number of electric field lines will be generated. Similarly, if we have a greater negative
Yes.
charge, so it will accumulate the more magnetic electric field lines. So their quantity, the number of lines is directly proportional to the source charge. Source charge mean either this is a positively charged body or it may be a negatively charged body. So the quantity of charge will determines the quantity of the electric field lines. Let's see, the next one is
Yes. Then there's a diagram of the positive, a positive point charge, and the electric field
repulsion.
lines are moving away.
Repulsion.
Yes,
Both the
repulsion from the point
both
charge.
are the positively charged.
Yes,
Both
so
are
the
positive.
electric field repels back.
Yes, similar charges are always repelling each other. So these two
Repelling
charges
each
are
other.
positively charged. So their repulsion is seen over here in their near what we can say the radius or the diameter. So they are repelling strongly, and when they are going away, so their bending is decreasing and minimizing their bending, because they are, when they are going away from these sources, so they are getting, what we can say, their intensity is becoming lesser and lesser, and their bending
Yes,
is also, we can see from this diagram that their bending is also decreasing. But when starting
decreases.
from the center, so they are bending, their repulsion power is greater. So that's why what we were saying, the magnitude of the charges are determining the nature of the electric field lines, their behavior, their bending, their propagation. So that is the main thing is, the greater the charges, greater the repulsion. Greater the opposite charges
Repulsion,
there, the greater the attraction, and there will be a
attraction.
less divergence. Now here we can say the divergence of the electric field lines are shown because they are diverted, they are repelling each other. Similarly, by putting the opposite charges, they will converge. The convergence of the electric field will be maximized when we have the opposite charges. So this is just a visual, we will have to visualize this by looking at this diagram. Now let's see what is the next is. Yes,
Challenge drawing electric field lines. There are three things wrong with part A of the drawing. What are they?
now
Part
let's
A,
we'll
positive,
think about that.
negative. So there's -2 point Q charge and it's moving towards. There is no intersection of electric field.
Now let me tell you one thing more is that in this diagram, especially in A part, so if you're
Yes,
just looking at the amount of the charges, we have the
yes, they are wrong. They are not
four
balanced.
positive and also four negative.
Yes,
Now you can see this. So
yes, I can see 4 negative, four
four, but the
positive.
propagation of the line's intensity, that is not
Yes,
justifying. What I mean to say,
the charge is,
the
yes,
4q is generating four lines to the minus q. So that must
yes.
be
Wow.
dividing to the greater amount.
Mine,
That must be
exactly.
minus 4. Minus 2 is greater than minus, but in the sense that these generations of the lines must be, we can see over there, because now the positive charge and the negative charge, they are evenly distributed in the sense. Now here we have only one q with a negative sign, and here
1Q,
we have also
negative
one
sign.
q, but here we have two q. This is a negative
Two
charge,
Qs.
two q's. So the cluster of the lines must go greater over here, and here this was
Yes.
going over there. So this is not possible. That cluster must move
Mm.
towards this charge, because it is a
Yes.
2q, and this is only 1q. This is also only
One
1q.
Q.
So here it's a justifiably, what we can say, distributed over there, because only 1q of negative and 1q of negative, and here we have
Negative.
the greater strength of the negative charge as compared to
Negative
these two
charge.
negatively charged particles. So that must be clustered over here, not over here. So this was what we can say. There are three things wrong with part A of the drawing. What are they? One
Yes.
is that their arrangement is not correct. The second thing
Yes.
is the
No.
number of the electric field lines are not justified. And the one more thing is that they are not properly
Yes.
placed. A diagram B is perfectly all right. So the next is electric charge and
Yes.
Coulomb's law. So I think we have talked about the Coulomb's law a bit of,
Yes.
and I have sent the recap video,
Yeah,
and
I have slides. Yes.
just it's a time to just take them with you and just make the comparison. What was that? But here we are
Yes.
just giving a little touch over there, because in detail we have talked
Okay.
about. So I
Yeah,
will,
we've already talked about it.
in the next coming slides, we will just only see the little relationship between the electric charge and the Coulomb law. In detail we have. So when I have checked all those presentation, so definitely I have made it, and there was the
Yes.
video recap was also there. And I am sure that I
Yes.
must have sent
Yes, I
definitely.
have.
Yes. Okay. Now it's clear now. So that's why I have taken only a little part of that Coulomb's law just to make a connection, the right connection with these electric charge. All right.
Fundamental charge. The charge on one electron is equals to 1.6 times 10 raised to the negative 19 coulombs. Unit
Coulombs.
of charge is a coulomb.
So it's a very basic information. So E
Yes.
is actually the amount of negative
Or of
charge. Each and every body has that of one
yes.
electron of every atom.
Yep.
Yes, if you
Two
can.
types of charges. Positive charge, a shortage of electron, and a negative charge is an excess of electrons. Principle of conservation of charge. The net charge of a closed system remains constant, or changes are either created nor destroyed, but can be transferred from one atom to another. Note, when charges come in contact, they share charges after contact.
Yes. So this is the whole story: the atomic structure, the formation of the covalent bond, ionic bond, and making the ionization. A lot of things are happening over there in chemistry. So we all know
Yes.
all those things, why these are charged and why the electrons are moving, and what is the valence electrons and why they are sharing and why they are making the
Yes.
different type of the bond. So we are not going in detail, but here, as a layman language, we are just talking about the positive and the negative charge, because there is the shortage or excess of the electrons in any atom, and the net charge will remain the same. It's what we can say, the zero sum game in the nature. So energy cannot be destroyed. Similarly, the charges cannot be created nor be
Not
destroyed.
destroyed.
They are just moving or shifting from one place to the other place. So
Yes.
it's a natural law. So it's happening all the time in everywhere, in everywhere
Yes.
in our life daily. So it's all about that. They are just transferring. They are just moving away and coming together, and whatsoever the phenomenon is. But the big reality is over there. What we have written over here in this slide. Now let's see.
Electric forces. Like charges repel and unlike charges attract.
So
Positive and positive will repel each other, negative and positive will attract each
from
other
the very
towards
basic,
each other.
very basic
Yes.
knowledge we are starting from. here, and we will just reach to the conclusion that what will happen when we have the different type of the charges. And that's why the last part, that maybe the next presentation, in which we'll talk about the electric potential energy. So gravitational potential energy we have talked about in the
Electric potential.
first year
Yes.
mechanics, but here in electrostatics we will
Electric.
talk about this in the next presentation. Coulomb's law.
Coulomb's law gives the electric force between 2 point charges. Force is equals to K constant, Coulomb constant, charge 1 multiplied by charge 2 divided by the distance between the two charges. And this is the Coulomb's law. The electric force is much stronger than the gravitational force. Coulomb's constant value is 9.0 times 10 raised to the power 10 raised to the ninth power Newton meter square per Coulomb square. Q1 is the charge on mass 1, and then Q2 is the charge on mass 2. R is the distance between the two charges.
So this is the what I have written over here, that no statement, no explanation, just only the mathematical format. The mathematical equation of the Coulomb's law is given. So we will have to make use of this. K is the constant, Coulomb's constant.
Yes, constant.
10⁹ Newton meter square per Coulomb square. So inverse square is due to the distance, and the direct is just the product of the charges. Two particle charges are placed at a distance of r, and we will have to get the force between the two electric charge body. Now if you can just, look at this
charges body. Example 1.
Two
40 gram masses, each with a charge of 3 coulomb, are placed 500 centimeters.
It's what we can say micro or microcoulombs are placed.
Yes, 3 microcoulomb.
Yes.
Placed 50 centimeters apart. Compare the gravitational force between the two masses, the electric force between the two masses. Ignore the force on the earth on the two masses.
So we are just taking it as an isolated system. We are not talking about the, what we can say, the gravitational pulse, because there is also a law, Newton's law of gravitation. So according to that law, there is also force of attraction between these two bodies. Because the statement of Newton's gravitational law is that in this universe, every body attracts every other body with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. So that definition is also applicable over here, but we are just neglecting that force of gravitation, and that force of gravitation is very, very less, because due to the greater amount of the capital value G, 6.67 10 raised to power minus 11 Newton meter per second square. So that was the, what we can say, a very small value when it is multiplied. So in generally we are not feeling that. So here, that's why ignore the force of earth on the two masses. So here we are ignoring the Newton's law of gravitation, and we are just taking it as these are placed in isolated system, where we are just looking for the electric pull, electric force, according to the, what we can say, the Coulomb's law of electronics.
Yes.
So here, now in the above the line, you can see that
is the gravitational
Newton's
force.
That is a very small 4.27 10 raised to power minus 13.
Minus 13.
It's a very, very big value. When you are putting 13 zeros and plus 2 zeros from here to 7. So minus 15 zeros will make a
15.
Now
Small value.
Below the line. So
is the electric force.
Coulomb's
is
law.
The Coulomb's law. K constant for the 9.0. Then there is a charge of both the electrons, and it's 0.324 Newton.
Greater than the gravity.
Relatively.
You can make the comparison of this Newton and Newton. This was approximately equal, and this is also approximately equal but you can think about which one is the greater. Which one is the greater?
The coulombs.
Yes, of course, because it's a minus 13.
There's minus
There is no
13.
component of multiple of 10. So if you are just using calculator or whatsoever the computer, so you will get this value is greater than this. So from here we can say that when you are applying both the laws, so when coming to the charge body, so we will have to neglect the gravitational force according to the Newton's law of gravitation, and we will have to take
Yes,
account
yes.
of only the Coulomb's law of electronics. For
Yes.
example, 2. Look at this. Example
Yes.
2. If you can read.
Three charged, three charged objects are placed as shown. Find the net force on the object with a charge of -4 microcoulombs.
Yes.
Then there's
So
this
we have
one,
written the Coulomb's law. We have placed them
Coulomb's law.
and we have put them this is the actual charge, and we will have to get the force F1 from here and F2 from here.
Yes.
And this is the distance, this is the length of this as per the
Length.
Pythagoras theorem, because it's a right.
Pythagoras theorem, a square plus b square is equal to c
So this
square.
will
Then
be
there's
28
a,
centimeter
b,
approximately.
28 centimeters.
So we will have to count first F1 from this and this, and here we are using, this is 4.5 Newton after making all these necessary calculations. Similarly, we can find F2 from this to this body, and after making the calculation, so we have
2.30 newtons.
2.30 Newton. So these are the
Yes.
two forces. F1 and must be added together as vectors.
Yes.
So
X
these are
vectors.
these are what we can say the resultant vectors. So when we are adding these two, so this will give us the uh, net force altogether of these two charged body on this red body, two charge body. We'll have to add these two forces. So we'll get the net result.
Net result.
So F1 is given in this case horizontal force,
Yes.
vertical forces, and then there the use of rectangular components of the vectors are being used over here, and the net force is when we are resolving these forces into their rectangular components. So net force is 3.31 and the angle is 29
Yes.
below the negative x-axis. So this is the whole geometry of this. I will send you all these slides so you can make a
Okay.
calculation in your own time.
Yes.
The third one is,
Two 8-gram equally charged balls are suspended on Earth are as shown in the diagram below. Find the charge on each of the ball.
so this is the arrangement, but you can say the two
Yes.
charged bodies are placed at a distance of some angle is also mentioned, and we will have,
Yes. We find the distance between we find the R,
yes,
the constant, and then you're given the electric, so we can find the
this will be
charges.
the diagram.
Yes.
Now
The
please read these questions.
two identical spheres A and B, 6 millimeters apart, have a charge plus 5 microcoulombs and minus 10 microcoulombs respectively. Calculate the electrostatic forces between them. Is the electrostatic force attractive or repulsive? The spheres touch one another and are repelled after touching to their original positions. What is the charge on each sphere after separation? How many electrons were transferred after touching?
So
Waste, and
I will send this slide and try to solve
I
this.
will solve it. Yes, I will solve this. Use scientific explanation model. What causes lightning, man-made or natural?
So what causing lightning? So you will have to search
Yeah.
this also. Next,
Okay.
or see your books that you will get the reasonable a few lines answer for this what we can say question. Sometimes these type of the question may be asked. Next is electric
Okay.
potential energy. So as we have seen that they are also behaving the two bodies, and when we are placing them, so we will get the electric potential energy. So that will be our next topic. Okay.
Okay.
So I will send these slides of this lesson, and the previous one was also ready. So in the today or tomorrow, I will send all these two lessons.
Okay. Okay.
These are the pending.
No worries.
If anything else is pending, so you can call me or you can send a message. So I will search out
Okay.
all
I
those
will let you.
lessons and will resend you. And you will have to also keep a close touch with your books. And if
Yes, I
something,
have books.
so
I
you
do the
must,
books after this lesson.
yes. So
After the lesson, I go through the books and everything.
go through the book, and if something is missing or any query is there, so you must settle your queries and quiz, and I will definitely do my best to search out all those answers if those are
Oh,
not explained in these presentation. So okay, thank you very much. Allah Hafiz.
thank
Take
you.
care of you
Allah Hafiz.
self. Okay, Allah Hafiz.
Allah Hafiz. Allah Hafiz.